per second per second. Yesterday we made the connection that velocity, the derivative of velocity is the acceleration, or the slope of velocity is acceleration, so that's important to know. Both are continuous functions. The table above shows selected values of these functions. For 0 to 60, must there be a time when the velocity is -5? Justify your answer. How do you know? It's continuous. It's -10 and then it's 0, right? Has to be -5 in between that. What theorem is that? Intermediate value theorem. It's old, right? That's an old theorem. We just have two values, and if we have a continuous function, we have to hit every value in between those two values. Y'all remember that theorem? That will be another one you need to have memorized. So, part A. Yes. Why? Okay, B of t is continuous on 0 to 60. That's the only qualifier on the intermediate value theorem, right? And B of 35 is -10. B of, what was the next one, 40? 50 was 0. And -5 is in between those two things, right? -5 is between, you can say this mathematically or just with words. B of 35 and B of 50. Therefore, by the intermediate value theorem, there exists, remember that backwards E for there exists, you can just say there exists if you remember it, a number C such that B of C equals -5. There exists C where C is between 0 and 60. Actually, not 0 to 60. What did I use? 37, 50? There is a C between 35 and 50 where B of C equals -5. Now, you don't have to say it exactly like I did by any means, but some things you have to say. You have to say B is continuous. You have to show that -5 is in between two of those B values, and you have to say something about the intermediate value theorem. Any questions about that? To answer this question, do you have to have the intermediate value theorem memorized? Yes, because practically I just wrote down the intermediate value theorem with this particular problem. So you will need to have all of those theorems memorized. Part D. For 0 to 60, must there be a time when the acceleration is 0? Justify your answer. And the first thing I'm going to do is look down on the acceleration graph. And that answer is no. Why is it no just on the acceleration graph? It never goes negative, so maybe not. Is that a good time to stop and say, nope, doesn't happen? What should I also probably look at? Okay, look up at velocity. Remember, what is the slope of velocity? Acceleration. So this is a great example of AP making you do both the intermediate value theorem and the mean value theorem on the same problem. And they put a really good distractor by making you think you couldn't do this with the intermediate value theorem. But if B of 0 is 20 and B of 25 is 20, which is what Haley said, essentially we're looking at Rolle's theorem, mean value theorem, special case. What's the average slope between 0 and 25 on velocity? 0. If the average slope is 0 at some point, didn't the instantaneous slope have to be 0? So even though you can't see that on the acceleration table because we don't have enough values, but could it dip below 0? Maybe. I just didn't see that part. So part B, or D, is also yes. V of t is both continuous and differentiable. Why do I need to say both continuous and differentiable? Because for the mean value theorem or Rolle's theorem, not only do I have to say continuous, I also have to say differentiable. AP won't make you explain how you know it's differentiable, but just out of curiosity, how do I know V of t is differentiable? A of t is a continuous function, right? Which is the derivative. So if the derivative is continuous, it's differentiable everywhere. Good. Now, you have a choice. You can either choose to use Rolle's theorem or mean value theorem. They say almost the exact same thing. I think Rolle's theorem is easier. You don't have to have Rolle's theorem memorized, so if you'd rather only memorize one theorem, you can work with it with mean value theorem. If I'm using Rolle's theorem, I then need to say V of, was it 0 is negative 20? And what was the other one? So I've met all of the qualifications of Rolle's theorem. Therefore, by Rolle's theorem, if you were using mean value, by the way, this little statement up here would be replaced by f of b minus f of a, b of b minus c of a over b minus a equals 0. So this little piece would be replaced by that. There exists a value c in the interval 0 to 20 where v prime of t equals 0. Mental note, v prime of t is a of t. Or you could just say a of t, which equals v prime of t equals 0. There are other ways you can say that. Maybe. Yes, I did mean 0 to 25. Thank you. There, hear her question and my answer. The x values were 0 and 25. So this one, you used a derivative of mean value theorem to take you down to the acceleration graph. So those are some tricky AP questions. Are there any questions about them? Okay. I probably will do a couple of limit review questions in a minute. But other than that, today, work on mean value number 2, work on AP 1, 2, 3, work on AP 4, 5, 6, 7, right? Whatever you need to work on, get as far as you can. You know that you've got some big AP deadlines Friday and Monday, so try to give yourself a little space on those.